Okay, in this problem we were expected to show that BC would be the same as AD. Now I've kind of sketched the picture here, but if you go to the notes, it's got a better picture of it. So I'm trying to get together to show that the blue sides are the same. What I do know is I'm going to do a flowchart proof here. And the plan for the proof was we're going to show that the triangles are congruent with one of the shortcuts. And then we're going to use CPCTC to show that the corresponding parts, in this case BC and AD, are congruent by CPCTC. So let's just think about this one for a second. And we were given a couple pieces of information. We were told that AM, so in red they gave us the information, A to M is the same as B to M. So let's write that down. So AM is congruent to BM, and that was given to us. We were also told something about the angles. We were told that angle A is congruent to angle B. That was also given to us. Okay, so it looks like we have an angle here, an angle pair, and we have a side pair. And so we have to figure out what do we still have. And it looks like there's something else. If you look at the center angles, angle 2 looks like it's the same as angle 1 because they're a vertical pair. So that would be a second set of angles. And so it looks like we're going to get, over here, we're going to get a set of angles. That's our first A. We're going to get a set of sides. That's our S. And we have another set of angles in the center. That's another A. So let's write that down. And so we have two angles in a side, and we'll see which one it works with in a second, which one it goes with. Some of you already know. And so we have one more piece of information. We know that angle 1 is congruent to angle 2, and that's because they're vertical angles. So the vertical angles theorem says that the vertical angles are congruent. And I said that that is another A for us. Now we don't need the red A's and stuff like that. And so what I'm going to do is, okay, so we've got that going. And now let's figure out what's really happening here. I'm going to make it less thick and do that in green. Okay, so we have a set of A's right here. We have another set of A's here, and in between we have sides that touch. So this is really ASA. We really have angle, side, angle, because we have angle, side, angle, and the same thing here, angle, side, angle. So it's really ASA, even though it looks like it's written here. So let's link all those ideas to show that the triangles are congruent by ASA. So the triangles are congruent by ASA, and we're going to name the triangles. So triangle A to D to M. It turns out A is the same size as B, so we're going to say congruent, okay, to triangle. B is the same as A. We went to D, so we're going to go to C, and then we're going to go back to M. So these ideas, these initial ideas that were given, and then we notice vertical angles, gives us ASA, that the triangles are congruent. And our goal is to say BC is the same as AD. Well, now that the triangles are congruent, we know BC and AD are the same. So we can write that as our last step. BC is congruent to AD, and that's the corresponding parts of congruent triangles are congruent. Okay, we've done the proof for that investigation.